For this video, I switched over to my note set, which includes some example problems, and those will hopefully be helpful for tying everything in that we've done at the end. Really, this set of chapters kind of all ties together nicely into some problems that we can ask and answer. So in the last video, we figured out that for the perfect competitor, the short run profit maximizing decision was you find marginal cost, set it equal to price, which is right here, and we produce the profit maximizing quantity A. All right, we can compare that and see whether we're making any profit to average cost. See that marginal revenue here, price, is greater than average cost at this quantity. So we're making a positive profit, and while average variable cost, or SVC, is not on here, we know that it would be similar to AC, similar shaped and below it. Right, so in the short run, the producer would produce a positive quantity Q1 and make these profits here. Okay, what about in the long run? In the long run, the firm uses variable quantities of both labor and capital, and so it's possible or likely that the long run cost curves would differ from the short run cost curves. Even so, we're still going to be using the same rule. Suppose that these are our long run marginal and average cost curves. So again, in the long run, we'll set marginal cost equal to marginal revenue and produce an optimal point E. All right, so what this graph is showing then, you might be wondering, what's this price down here of $30? What this is showing is that in the long run, marginal cost equals marginal revenue at a price of $40 occurs here, and that's above this long run average cost. So in the long run, our perfect competitors would be making positive profit, but we have to consider the free entry and exit assumption. If we were producing right here and making the positive profit, because of free entry, firms will continue entering the market, pushing the price down to $30. Right, so now firms have entered the market, the price has fallen to $30, and we set MC equals to MR at $30, we find zero profit. Right, so the long run equilibrium here would be a price of $30 where firms are making zero profit. And that's because if the firms were making profit at, say, a price of $40, more companies are going to enter the market because they can and make positive profit all the way down until zero profit point. Likewise, if in the long run the price was too low and firms were losing money, price was below average total cost, firms would exit the market. That would push the price up back to the point where long run marginal cost equals long run average cost equals price, this point right here. Or in other words, the point of zero profit. Okay, so hopefully that piece of reasoning is a little bit similar from if you did perfect competition in 202 and studied zero profit. Again, the idea is that in the long run, firms can enter and exit at will. If there's positive profits to be had, firms will enter, driving down the price to zero profits. And if there's negative profits, if firms are losing money, they exit the market, driving up the price to zero profits. All right, so our conclusions about competitive markets, we use MR equals MC in order to find our profit max point, both in the short run and the long run. That implies price equals marginal cost is our rule for the perfect competitor. In the short run, it's possible to have positive or negative profits, but in the long run, entry and exit guarantees zero profit. So that's kind of what we were just doing with this graph. We also are going to maintain the idea, although we haven't really looked at a graph, equilibrium is still a price such that quantity supplied equals quantity demanded. Right, we've been focusing mostly here on the supply side. All right, so let's tie it all together then with a couple example problems. Really, the main theme of this chapter was figuring out how the perfect competitor finds the profit maximizing quantity. And then in previous chapters, we looked at if we know a particular quantity, what's the cheapest way to produce it. So that's what we're doing up here. It's worth noting that in chapter 7, we derived a total cost function in terms of our inputs. We know that in the 2-input model, the inputs that we'll be using are labor and capital. So we can write our total cost as equal to WL, wage times number of laborers, plus RK, rental rate of capital times how many capital we have. Right, so that means we can write our profit, total revenue minus total cost, as total revenue still minus our total costs. So total revenue minus WL minus RK. So here's our total revenue. Here's our total payments to inputs. Right, we can also write that as PQ minus WL minus RK, substituting in for total revenue. So the question here is, suppose a producer has a technology production function, Q equals L to the 1/2, K to the 1/2. We've got P equals 10, W equals 3, and K equals 6. What is the producer's profit function as a function of L and K only? All right, well, we know the profit function is going to be total revenue, PQ, minus total cost, WL minus RK. So this part of it is already in a function of L and K. We can plug in our prices, got 3L minus 6K. What about our total revenue? Well, we know Q equals L to the 1/2, K to the 1/2, so we can plug that in. We know the market price of 10, so we plug in 10, Q is equal to 10, L to the 1/2, K to the 1/2, minus our costs. Right. Suppose that we also know, in addition to this profit function, that our total costs are equal to 5 plus 0.02 Q squared. What is the perfect competitor's profit maximizing quantity choice? Well, our rule for profit maximizing is P equals MC. So that's true short run or long run. So P equals MC, we know that price is equal to 10 from before. So 10 equals marginal cost. We need the derivative of total cost with respect to Q, 0 plus 0.04 Q to the 1 power. All right, so we know price 10 equals our marginal cost, the derivative of total cost with respect to Q. We solve for Q and get Q equals 250. Right, so that's kind of the new stuff that we did in this chapter, right? You know, some total cost function, what is the profit maximizing quantity choice, and then we can say some things about what the profit is and whether the firm would rather shut down or stay open. I have some additional example problems of that from the previous section we'll do in another video. But now we know that the producer would be maximizing profit to choose a quantity of 250. We also know the production function. We know input costs. And so from chapter 7, we can figure out what is the cost minimizing way to produce this profit maximizing quantity of 250. Right? We know that the answer to this problem is going to be the point that MRTS equals W over R. We have a production function, so we can find MRTS. We have W, that says K equals 6, but this should be R equals 6. I'll make sure to change that. So R equals 6 here, W over R equals 3/6. So we find MRTS. I've skipped some steps here. Hopefully finding MRTS is getting quicker for you, but we take MPL, we divide it by MPK. We're going to get K over L, set K over L equal to our price ratio, 3/6. We can write K in terms of L, and we can plug it into our production function. We know we want to produce 250. We've got K in terms of L, so we plug it in and we solve. All right, I have an example here for perfect substitutes. It looks like we could do this for perfect complements as well. As soon as we figured out here, example 10, what the profit max quantity is, then we're just back into previous chapters. Chapter 7, we have our Q, we have our production function and our prices, so we can solve like we were doing then. Right, let me know if you have any questions.